Hello friends, welcome to the class of high voltage engineering. So in previous lecture I have discussed about the dielectric test on circuit breakers, in which I have specifically discussed over the power frequency withstand voltage test under the dry condition and under the wet condition. In today's lecture I am going to discuss about the short circuit test on circuit breakers. So apart from the dielectric test, as one is know that the dielectric test is usually performed to assess the quality of the insulation, whereas to assess the specifications of the circuit breaker and the performance of the circuit breaker, the direct testing and the indirect testings are conducted. So if suppose one wish to assess the performance of the circuit breaker, the indirect testing is generally conducted, which consists of two different types. One is known as a unit testing and second is known as a synthetic test. So indirect testing is not a scope of this lecture. In the next lecture after this I will discuss about how the synthetic testing is conducted and how the performance of the circuit breaker can be evaluated. In today's lecture I am going to deal with the direct test, specifically or broadly known as a short circuit test on circuit breaker, which is intentionally conducted to assign the rated characteristic of circuit breakers. So let us move ahead. So short circuit test on circuit breakers. So here you can see I have represented the short circuit plant layout, which is used to test the circuit breakers for assigning its rated characteristic. The rated characteristic, it means you will get the information related to the data which you can read on the nameplate of the circuit breakers. So to check the circuit breaker whether it is properly designed as per the specifications which are given on the nameplate of circuit breaker, the short circuit testing is conducted. So prior to go in the steps or the procedure to know that how to conduct the short circuit test, first one has to understand about the different compartments of this short circuit plant. So here I have represented a simple circuit arrangement of the short circuit testing station, which includes short circuit generator, as you can see over here. It includes a driving mechanism, impulse exciter, master circuit breaker, the variable resistors, variable reactor, making switch, okay, then the capacitive links, short circuit transformers, and at the end you will found one basement or the housing where you have to place your circuit breakers and connect to this short circuit testing plant to assign or to assess its rated characteristics. Okay, so these are the different compartments on which I am going to first discuss, and afterwards it will be very easy enough to understand that how the circuit breakers are tested for its breaking capacity, making capacity, short time current carrying capacity, and its duty cycle. So let us start with the flow of the equipment which are used in short circuit testing station. So number one is the short circuit generator, which is coupled with the driving motor, which is usually a three-phase induction motor. Okay, you know that to drive the generator's rotor it needs the external coupling. Okay, means the external rotating unit must be required. So in case of the power plants, generally the generators, the rotor of the generator is coupled with the turbines, okay, the mechanical rotary equipment which drives the generator and induces the EMF. Okay, similarly in case of this short circuit testing plant, we cannot use the turbines. Okay, so instead of using those turbines, the three-phase induction motors are likely to be connected or coupled with the rotor of the short circuit generator. The requirement of this short circuit generator is to provide the short circuit current at a required level of test voltage, which you can consider it as a one sort of the recovery voltage. Okay, so the EMF which is induced by this short circuit generator is basically known as to be the recovery voltage. Okay, and yes, in case of the power plants, whatever the generators you are finding are having the separate excitation. So here the impulse exciter is used. So role of impulse exciter is somewhat different as compared with the excitation system that you are observing at the power plants. So let us quickly move towards the points related to the different components or the different equipments that we observe in case of the short circuit testing station. In industries, it is also known as a short circuit bench. Okay, so let us discuss about this short circuit generator and its driving mechanism. So short circuit generator provide power to the circuit breakers which are under the test. Okay, so short circuit generators must be capable of withstanding extremely high reactive power surges lasting for a very short duration. So if you are considering the design of this short circuit generator is completely different from the conventional alternators, because the duty of the short circuit generator is to produce or to give the short circuit current to the circuit breaker which is under the test to assess its breaking capacity. Okay, so during the generation of this short circuit current, the generators winding and the insulations must be capable enough to withstand the larger magnitude of the magnetic forces which are created. Okay, so ultimately the generator must be capable enough to withstand extremely higher reactive power surges which are lasting for very short duration. So the design is obviously different as compared to the design of the conventional alternators. The short circuit generators must have the low reactance just to tackle with this high reactive power surges. Okay, so the low reactance will give to can provide us the maximum short circuit output. The short circuit generator is a three-phase alternator. So each winding is made into in two or more parts, which either can be connected in series or in parallel compensations for the compensation of star or delta to provide different terminal voltages. You can see that the generator is coupled with this driving motor. So it is of course three-phase type induction motor which is connected to a resilient shaft. Okay, the generator is equipped with built-in flywheel which provides the kinetic energy during the short circuit and speed regulation of the test setup, means this motor generator set. The another is the impulse exciter. Okay, let me highlight it. So here you can see this is the impulse exciter. So this is especially a DC converter set with the high peak output provides the impulse excitation. The impulse excitation, or in other words it can be known as a super exciter or super excitation, is to provide the or to counteract the demagnetizing effect of armature reaction. Why? Because the short circuit current which are at a lagging power factor have a demagnetizing effect, and you know that if you know the influence of the demagnetizing effect, it will result in a reduction of total field. So what exactly happens? As the field gets reduced, flux gets reduced, it reduces the EMF. So as a result, the recovery voltage will be lesser than the voltage just before the short circuit, which is not our requirement. Okay, so to get the enough test voltage, we have to strengthen the electric field, and to strengthen the electric field we have to counteract the demagnetizing effect which is produced because of the armature reaction. Okay, so the effect can be reduced by boosting the generator field current by means of impulse excitation. So that is the role of the impulse exciter. The impulse exciter will counteract with the demagnetizing effect of armature reaction and strengthen the field which is lost due to the demagnetization. The converter set employed for providing impulse excitation is filled with a large flywheel, and the motor is disconnected. Okay, so the special care has to be taken while you are switching on the impulse exciter. Okay, so when you are switching on the impulse exciter, first the test engineer has to disconnect this driving motor, otherwise this impulse excitation may create harmful damages to this driving mechanism. So motor is disconnected from the supply before the application of excitation. The field current is increased shortly to about 10 times its normal value at the instant of short circuit. Okay, so you can imagine that the larger magnitude of the forces, the tremendous forces may observe at this coupling. Okay, so it may destroy the shaft of this machine as well. Okay, so to prevent the damages to these driving mechanisms, the motor has to be disconnected before the application of impulse exciter. Okay, so this takes care of demagnetizing effect of short circuit and provides the desired recovery voltage. The another is the pilot generator. So the pilot generator is nothing but it is a three-phase alternator which is directly coupled to the main shaft of short circuit generator and synchronized in phase with the later one. Okay, so it will be synchronized. Whatever the pilot generator has been coupled with this main shaft of short circuit generator is obviously need a synchronization, proper synchronization with the short circuit generator. So any present voltage is maintained constant by automatic voltage regulator during the short circuit test. So this dependable voltage is required to supply the control power to the sequence timer, electromagnetic oscillograph, and the various actuating circuits for the conduction of the test. So this is the requirement of the pilot generators. The short circuit transformer, as you can see over here, the short circuit transformers are employed when the test voltage is different from the generator voltages are required. Okay, so that is the basic necessity of these short circuit transformers. Okay, so by using these short circuit transformers, one can produce the required value of the test voltage, which is other than the generator voltage. So for stepping down the voltage, a three-phase transformer is normally used, whereas for stepping up the voltage, the bank of single-phase transformers are being used. So again, the design of the short circuit transformer is completely different than the conventional transformer. So they are designed to withstand the repeated short circuit, and their windings are often arranged in sections for the voltage adjustment in series and parallel combinations. The leakage reactance of this short circuit transformer is kept low, so the transformer winding is mechanically strong and provide with the extra turn insulation because of this larger voltage and the larger current magnitudes. For three-phase test, the transformers are connected in delta on the alternator side. The four windings of each phase of secondary side can be connected in series parallel combinations, and three phases can be connected in star or delta. So depending upon the type of the test to be carried out in the test cell, the different types and ratings of transformers are connected in different test cell. As you can see that per cell there is a one transformer. Okay, so high voltage testing transformer in one and low voltage high current transformer in the other. Resistors and the reactors. So for controlling the short circuit test current, three-phase bank of resistor and reactors are used. Okay, so purpose of this resistor and the reactor is now clear, that they are used to control the short circuit current. So reactors are being used for the adjustment of magnitude and the resistors for the control of rate of decay of DC component of the current. So if you memorize the waveform for the short circuit current, at initially you find the AC component and the DC component, because of the RLC component of the transmission line, the fault current consists of the AC component as well as the DC component. So rate of decay of that DC component can be controlled by the three-phase banks of resistors, and the magnitude of that short circuit current can be controlled by this reactor. Okay, you know that the reactor's function, that it controls the rate of change of current with respect to the time. The short circuit power factor is also controlled by these means. Okay, so simply here you have the simple RL circuit. So short circuit power factor can also be controlled, and there are a number of coils per phase, and so many variations can be had by the connecting them in series parallel combinations. The another is the master circuit breaker. Okay, which you can see over here. This is the let me erase this so that one has the clear picture. Sorry again. So master circuit breaker, you can find it over here. Okay, so this is normally the air blast type of capacity more than that of the breakers which are under the test. So it is provided mainly as a backup circuit breaker. So if during the testing the circuit breaker under the test fails to operate or fails to break the circuit, the master circuit breaker has to operate it. Okay, so otherwise what happens, it may create the severe damages either to the transformer side or to the capacitor links or the resistor or the reactors, or it may cause a serious damage to the short circuit generator. Okay, so to avoid this financial crisis due to that damaging effect, if the circuit breaker under the test fails to operate, the master circuit breaker has to operate it. In case of failure of the test circuit breaker, the master circuit breaker gets open. In addition, after every test, it isolates the specimen under the test from the supply source and must be capable of handling the full short circuit power of the test circuit. Make switch, here you can see this is the make switch. So it is also the air blast kind of switch, the making switch, or it can also be known as a making device. So it is employed to ensure that the short circuit currents are applied correctly at the desired moment. Okay, so the equipment is characterized by close making time and high making capacity. So breaking capacity of this making switch is negligible, as making device is not intended for the purpose of circuit interruption. So at the moment of making or closing the make switch, the backup circuit breaker and the test circuit breakers are already closed. Okay, so first you have to close the master circuit breaker and this circuit breaker under the test. After that you have to close this making switch, because the requirement of this make switch is to supply the short circuit current at a desired moment. So as such, on closure, if there is even a slight contact rebound, the contacts might get burnt or even welded together. Okay, by any way you can make this switch in a closed condition. So in order to ensure that the contact separation is minimum on closure, a high pressure is maintained into the chamber of that making switch. So the closing speed is also so high that the contacts are fully closed before the short circuit current attains its peak magnitude. The another is the capacitor links, which you can see over here, which is just connected right before the short circuit transformer. So capacitor banks normally used for serving the two purposes. Number one, it provides a leading current for testing the performance of circuit breaker in interruption of charging current, and second, it controls a rate of rise of the striking voltage. Okay, where the frequency can be calculated from this formula 1 upon 2 under root LC. Okay, so from this uh, one can imagine that how this capacitor will help in controlling the rate of rise of restriking voltage, because the frequency of that restriking voltage is completely different from the frequency of the recovery voltage. So to control the restriking voltage, one has to control the frequency, and the frequency can be controlled by connecting these capacitor links. So in synthetic testing and the other indirect tests, the capacitors are very important items in the test circuit. So these are the single phase banks and can be connected in series parallel combinations as desired, both individually or even in combinations of three can also be used. The test cells, as you can see, okay, so normally the specific term which is used as test cell is the cubicle in which one has to place the circuit breakers. So these are the construction of this concrete work or a strong brick work. So there is a provision for the observation. So there is a glass window through which one can analyze the situations during the test. Supply of the compressed air and oil purifying system is given to the test cell for facilitating testing of air blast circuit breaker and the oil circuit breakers respectively. The separate test cubicles are provided for testing low voltage, high voltage and extra high voltage circuit breakers, and each test cell got an end box where the control and measuring cables are terminated. The contacts are fully closed before the short circuit current attains its peak magnitude. The test control room, so generally it is situated nearly at a distance of 20 meters from the test cubicles and is provided with control desk for the remote control operation of the excitation of short circuit generators. So these are these control rooms normally equipped with oscillographs, distribution panels, electromagnetic oscillographs, cathode ray oscilloscopes, and the electric sequence switches and the electronic sequence switches. So it is designed to provide facilities for the conduction of the test. Safety and signaling system. So foolproof interlocking system is provided for safety of working personnel, as enormous electrodynamic stresses or the forces are brought into play during the short circuit testing. So this system makes the excitation of machines impossible if any of the door leading to machine hall, basement reactor room, etc. remains open. So if suppose if the room is open, then it won't be allowed to start the test. A system of audio-visual alarm is also provided as a warning before the short circuit. So these all are the different compartments of the short circuit testing laboratories. Now let us see that how the short circuit test is being conducted. Okay, the same circuitry used to perform the short circuit test on the circuit breaker. So first, the preliminary checkup of various equipment is made before the actual commencement of the test. First, you have to see that is there any kind of the loose connections are present or not. So first, you have to satisfy with the connections. The correct values of resistance and reactance coils are inserted as per the magnitude of the short circuit current. So you have to set the values for this resistor and the inductance. The transformers are properly set and the measuring circuit are connected and oscillograph loops are calibrated. The sequential switching of the equipment measurement and the control circuit is accomplished by a sequence switch. Then the sequence switch is a drum switch with several pairs and contacts. So drum is rotated by the motor. Once the drum is rotated, it closes and opens the several control circuits according to the certain sequence. Okay, so these are the basic needs which you have to first configure prior to conduction of the test. So let us see the sequence for testing the braking capacity of the circuit breaker. So first, what engineer has to do, after running the driving motor of short circuit generator to a certain speed, it will be switched off, because we need to now switch on the impulse exciter to counteract the effect of demagnetization to obtain the required recovery voltage level. So after disconnecting the driving motor or decoupling the driving motor from the generator side, the impulse excitation will be switched on. Afterwards, the master circuit breaker is closed. The oscillograph circuitry is connected. Afterwards, the making switch is closed and the circuit breaker under the test must be open. Okay, so first you have to close the master circuit breaker and circuit breaker under the test. Afterwards, you have to supply the short circuit current at a desired moment, and it can be applied by closing the making switch. So once you close the making switch, the short circuit current is being applied to the circuit breaker. Okay, and the circuit breaker has to break the circuitry on the application of short circuit current. Once it will be opened, the master circuit breaker is switched off, then exciter is switched off and its field is suppressed. Okay, so these are the 8 steps to conduct the braking capacity test over the circuit breaker. So this operation usually takes a time of 0.2 seconds. After the completion of this test, the starters of the drive motor of the short circuit generator and exciting machines are automatically reset to a lower degree. The motors are then switched on and allowed to run at the full speed. Okay, allowed to run the full speed so that in a short time the further short circuit can be initiated. So these are the these are the sequences in which the circuit breaker braking capacity test is being conducted on the circuit breakers. So let us see the test for the braking capacity. So generally over the screen of the scopes, one can observe these two kinds of the wave shapes. One, that is the short circuit current waveform, and second, the waveform which you are capturing is the restriking and the recovery voltage waveforms, from where one can determine the magnitude of the arc voltage. Okay, then the instant at which the arc has been extincted, okay, the arc extinction. Then one can determine the magnitude of restriking voltage and the recovery voltage. So to conduct this braking capacity, the master circuit breaker and the circuit breaker under the test must be closed. Afterwards, the short circuit current is allowed to pass by closing the making switch. So the parameters which has to analyze during this test are this. Okay, the short circuit current is interrupted usually by opening the circuit breaker under the test at desired moment. So the measurements which the engineers has to take out from this test is the symmetrical braking current. Okay, The second is asymmetrical braking current, which you can observe from this area. The recovery voltage and the frequency of oscillations and rate of rise of restriking voltage. So these are the two normal wave shapes one has to capture while performing the braking capacity test. So circuit breaker must be capable of breaking all the currents up to its rated capacity. So it is not possible to test at all the values of current. So the tests are usually performed at 10%, 30%, 60% and 100% of its rated braking current. Okay, so in a step by step you have to go. First you have to test the breaker at 10% of its rated current, rated braking current, then 30%, then 60% and then 100%. So this is how the quality in terms of its braking capacity can be evaluated. Now for the test of making capacity. So the master circuit breaker, okay, to test the making capacity, first the master circuit breaker and the make switch are closed first, then the short circuit current is initiated by closing the circuit breaker under the test. The rated making current, as you can see over here, the peak value, the first peak magnitude, okay, the peak value of the first major loop of short circuit current wave is measured. So while performing the making capacity test, the expectation is the circuit breaker contacts must remain in a closed condition. Okay, so to observe this phenomena, first master circuit breaker and the make switches are closed. Afterwards, the short circuit current is allowed to flow by closing the circuit breaker under the test, so that one can easily evaluate the making capacity of the circuit breaker. Test for duty cycle. So this is the sequence. B3, B3, B. Tests are performed at 10%, 30% and 60% of rated symmetrical braking capacity, where B denotes a braking operation. Okay, and 3 is the time interval, usually in terms of minutes. Okay, so between the two successive applications there will be the waiting of 3 minutes. The another is B3 MB 3 MB. Okay, so MB denotes making operation followed by the braking operation without any intentional time delay. So it can be performed at not less than 100% of rated symmetrical braking capacity and not less than 100% of its rated making capacity. So this test can also be performed as two separate tests, M-3-M, which is known as a make test, where M denotes making operation, B3B3B, that is a brake test, and B3B3B tests are performed at not less than 100% of its rated asymmetrical braking capacity. So this is how the test for the duty cycle is being conducted on the circuit breaker. So generally the short circuit test or the direct test is the test which can give a brief idea related to the specifications of the circuit breaker. So this is about the short circuit test on circuit breaker. One last test of short time current rating. The rated short time current is passed through the circuit breaker under the test for a specified short duration, 1 second or 3 seconds. It usually depends upon the ratio of the braking capacity to the rated current. So and the current is measured by taking an oscillograph of the current wave. The short time current should not cause any mechanical or insulation damage or even any contact welding. Okay, so all these specifications can be verified by conducting the short circuit test on circuit breaker in short circuit laboratories by using the short circuit test plant. Thank you.